We begin Unit 14, Graphing Rational Functions. Here's the graph of x plus 3 divided by x plus 2. This is a rational function. A rational function is a function made up of a polynomial in both the denominator and the numerator. The domain of a rational function includes all real numbers except the x values that make the denominator 0. So what would make the denominator of f of x equal to 0? To find out what would make the denominator of f of x equal 0, set x plus 2 equal to 0 and solve for x. So if we subtract 2 from both sides, we get x equals negative 2. If you notice in the graph, when x is equal to negative 2, we have what's called a vertical asymptote. This is a boundary line that the picture in our graph does not cross. What would make the denominator of f of x equal to 0? That's negative 2. And the vertical asymptote of f of x is x equals negative 2. Now this is an equation, so we do need to have the x equals. Identify the vertical asymptotes of the following graphs. Notice our picture does not cross the line x equals 1. So the vertical asymptote is x equals 1. In the second graph, our picture does not cross the line x equals 0. So the vertical asymptote is x equals 0. In the third picture, there are two asymptotes. The first asymptote is at x equals negative 3. The second asymptote is x equals 2. Ignore these in your graph. The picture is accidentally turned upside down. Match the graphs with the rational functions. The easiest way to do this is figure out what makes the denominator equal to 0. In the first equation, set the denominator x equal to 0 and solve for the variable. This is the vertical asymptote. The answer that matches this equation is graph number 2. In the second equation, set the denominators equal to 0, set the factors equal to 0, and solve for x. X is equal to negative 3, or x is equal to 2. Both of these are the vertical asymptotes. This matches graph number 3. And the last one, set x minus 1 equal to 0 and solve for x. So x equals 1. This matches graph number 1. Now let's state the domain and find the vertical asymptotes for the following rational functions. To do this, set the denominators equal to 0 and solve for x. The vertical asymptote is at x equals negative 2. So the domain is all real numbers except where x is equal to negative 2. So x is not equal to negative 2. And number 5, we need to factor first. So I have 2, and this is a difference of squares, so x plus 3 times x minus 3 divided by x plus 2 times x minus 2. We do not have common factors, so at this time set the denominator equal to 0 and solve for x. So x is equal to negative 2, or x is equal to 2. So the vertical asymptotes are x is equal to 2 and x is equal to negative 2. The domain is all real numbers except when x is equal to negative 2 or 2. Number 6. We could factor first because this is a sum of cubes, but I don't need to do that in this problem because this is just x squared in the bottom. So set x squared equal to 0 and solve. If we take the square root of x squared, x is equal to 0. So the vertical asymptote is at x equals 0. The domain is all real numbers except where x is equal to 0. So x is not equal to 0. Number 7. Factor. Take an x out of the denominator and set each of these factors equal to 0 and solve for x. So x is equal to 0 and x is equal to -3. Those are the vertical asymptotes. The domain is all real numbers except where x is equal to 0 and -3. Last problem. X squared minus 4. This can be factored to be x plus 2, x minus 2. The bottom, you can use the snowflake method to factor, but you should be able to do this in your head. X times x is x squared. These are both positive because both of these are positive. And the number that multiplies together to give you 3, but add to give you 4, are 3 and 1. There's no common factors in this problem, in the top or the bottom. So at this point, we set each factor equal to 0 and solve. So x is equal to -3 and x is equal to -1. So those are the vertical asymptotes. The domain is all real numbers except where x is equal to -3 and -1.